In problem number 16, we need to calculate the double integral of the function x plus y with respect to the area over the region of integration, which is the square in the xy plane. The side length of the square is 4, and the vertices are at the points 0, 0, 4, 0, 4, 4, and 0, 4. We calculate double integrals by iterated or repeated integration. The first step is to decide which variable we would like to integrate over first. In this particular example, it wouldn't matter. We could integrate over x variable first, or we could integrate over the y variable first. The answer would be exactly the same, regardless of the order of integration. Now, in more complicated double integration problems, the order of integration may be important, not in terms of the answer being different. The answer will always be the same regardless of the order of integration, but one order of integration may be easier to calculate than the other. Now let's integrate over x here first, and I'm just choosing that order of integration randomly. If we're integrating over x, the y variable is kept fixed at a certain value. So if you can imagine, if I'm selecting a certain value of y, and I let x coordinate vary, the point that represents, that has that x coordinate and the y coordinate that is fixed at that value that we've selected, will be located at the horizontal line, like this. Now we're only interested in points that are inside the region of integration, and the points inside the region of integration having a fixed y coordinate will be located on this horizontal line segment, which we call a horizontal cross section of the region of integration. So this horizontal cross section represents a typical segment over which we integrate our function. Our function is x plus y. Now x is the variable of integration, so the x values range from the left end point to the right end point, and the value y is kept fixed. Now you see here that the left end point of the cross section has the x coordinate equal to 0, and the right end point of the cross section has the x coordinate equal to 4. And so the interval of integration for our first integration over x is from 0 to 4. So we're integrating from 0 to 4 over x. And once this integration is completed, by the way, the answer will be a function of y. We will not get a number because we don't have a value of y specified. And then, so once we have the result, we can integrate the result over y variable. And you can see that for the points inside our region of integration, the y coordinate ranges also from 0 to 4. So our second integration will also be from 0 to 4. Okay, so let's do our first integration. We're integrating x plus y over x. Y is a constant, and the integration is from 0 to 4. So first we need to find the antiderivative of the function x plus y with respect to x. That antiderivative is x squared over 2 plus y multiplied by x. And we will evaluate this antiderivative at the endpoints of the interval of integration, 0 and 4, and then we will calculate the difference, and that would give us the value of the first integral from 0 to 4 of x plus y dx. Once we've done that, we will integrate the result with respect to y, again from 0 to 4. Very good. So let's see what we get when we evaluate the antiderivative x squared over 2 plus yx at the endpoints. If I substitute x equals to 4, I'm going to get 4 squared over 2 plus y multiplied by 4. I have to subtract what I get by substituting instead of x 0, 0 squared over 2 plus y times 0. All of that in the second term, and that we're subtracting is 0, so we're really subtracting 0. And okay, so then let me simplify a little bit the function that we're integrating. In terms of y, I get 4 squared over 2, that's 8, plus 4y. And this is a regular definite integral of a function of one variable, y. So we use the fundamental theorem of calculus to calculate this integral. The antiderivative of 8 is 8y, plus the antiderivative of 4y will be 4 times y squared over 2. And we'll be evaluating this antiderivative at the endpoints of the interval of integration, 0 and 4. Again, if we plug in 0 for y, we're going to get a 0 result. And so we will get then 8 times 4 plus 4 times 4 squared over 2, 32 plus another 32, which is 64. And so the value of our integral is 64.